There is a type of probability question that I always see students fall for, and I thought it's long overdue that I do a separate video focused on this unexpected probability trick. I call it unexpected because the way you work it out doesn't really feel like some of the other probability questions that you might be used to. Now, I've only got 2 questions because it's a fairly simple trick, but with this question that you can see on screen, feel free to pause the video, try it yourself to see if you get it right, and then if you don't, you can see my method. But even if you do, the next question following it is going to be even harder. If you get them both right, then well done, you are definitely on your way towards a mastery of probability. Let's look at this trick first and this question. There are 10 pairs of gloves in a drawer, and each pair is a different colour. If Lolu picks 2 gloves at random from the drawer, what is the probability that they are not the same colour? Now, what you probably already know is that we have a choice in probability. We can either work out the thing that they're asking or work out the opposite of what they're asking. We decide, is it easier to work out one or the other? In this case, it might be easier to work out the probability that the 2 gloves are the same colour. That strikes me as being easier than working out the probability that they are different colours. Of course, once we've worked out the probability that they're the same colour, then we can do 1 minus that answer to get the probability that they are not the same colour. Always bear that option in mind when you're doing probability questions, that you can choose to find directly the probability they're asking for, or the opposite of what they're asking for and do 1 minus result. Either way, let's get to the actual trick though. How do we find the probability that they are the same colour? And this is where so many students would get stuck. They would say to themselves, okay, we've got 10 pairs of gloves. That means that there are 20 gloves in the drawer. But they're 10 pairs, right? So 10 different colours, 2 gloves each. And they're thinking, but what colour am I aiming for? We want 2 of the same colour. Well, I guess let's just say red is one of the colours. So we've got a 2 out of 20 chance of getting a red glove, and then maybe a 1 out of something chance of getting the next red glove. Then it gets an answer way smaller than these. And then students get really confused, basically. They're not sure what to do. Well, here's the trick. Sometimes the first choice is no choice at all. If we want to pick out 2 gloves of the same colour, we're going to have to think about this glove by glove. And let's focus on that first glove choice. I know it says she picks 2 gloves, but we are allowed to, and I encourage you to, think about that as one choice followed by another choice. So on that first choice, does it matter what glove she picks? This is the heart of the trick that I'm trying to tell you. She's going to pick out 2 gloves and we're going to do it one by one. And when she picks out that first glove, if we're aiming for 2 gloves of the same colour, does it actually matter what colour the glove is on that first choice? No, because we're not aiming for a particular colour. We're not aiming for 2 red gloves or 2 green gloves. We're just aiming for 2 gloves of the same colour. So on that first choice, she actually has a 20 out of 20 chance, a guaranteed chance, that she picks an appropriate glove, because we actually don't care what she picks the first time. She could pick a red one, a green one, it doesn't matter. It's the second choice where we want the glove to be the same colour. The first choice doesn't matter, and that's why I call this the unexpected probability trick. Out of the 20 gloves available, she can pick any of the 20 for her first choice, and that's why we have 20 out of 20. But once she has chosen that first glove, now we have to think about, for her second choice, what's the probability that she picks a glove of the same colour as the one she's already chosen? So now it's not 20 out of 20. There are 19 gloves only left in the drawer, and she has to pick, if we're aiming for the same colour, the exact same colour as the one she already picked. So what's the probability? It would be 1 out of 19. The 19 because we've already taken 1 glove out, so there's only 19 gloves in total left. And the 1 because it has to be the one matching glove to the one we've already picked out. So say that she picked out a blue glove the first time, it would have to be the one remaining blue glove the second time. It can't be any other colour. Of course, with probability, we're going to multiply because she has the first choice and the second choice, so we multiply. And 20 out of 20, funnily enough, is just 1. Anytime the numerator and denominator are the same, that's just 1. So it's 1 times 1 out of 19, which is 1 out of 19. And we have ascertained that the probability she picks 2 gloves of the same colour is 1 out of 19, which is really freaky, but it makes it quite easy now to see that the probability that they are not the same colour would be 1 minus that, which is 18 out of 19. So that's the lesson in a nutshell. Think about things choice by choice and decide what we are allowed for the first choice and what we are or are not allowed for the second choice. Don't try and scramble them together or think of them as a group. Just sit back and think about your first choice and think about what's allowed. If we want 2 gloves of the same colour, any out of the 20 will be allowed for that first choice. Now it's going to be different numbers for the next question and a different scenario, but I want you to use that same approach where you don't try and lump things together. Just sit back, relax, think about the first choice, decide how many options you have. Then once you've made that choice, think about how many remaining options you have for the second choice. As before, feel free to pause the video and answer this question yourself before you see my explanation. And for the GMAT, I would estimate this is a 700 plus level question. For the GRE, somewhere between a 165 to 170 level question. There are 12 children in one class and 25 children in another class. There are 3 pairs of twins split between the classes, with 3 of the children in the smaller class each having a twin in the larger class. If 2 children are selected at random, 1 from each class, what is the probability that they are sibling twins? Okay, so one choice at a time, as I've written down below. Let's focus on our first choice from that first class. How many of those 12 children, and we're going to pick one of them, are we allowed to pick if we're aiming for sibling twins between the 2 classes? The answer would be 3 out of 12. Because we're not looking for a particular pair of twins, so that would be 1 out of 12. We're looking for any sibling twins. So for that first class, obviously we can't pick one of the 9 children that don't have a twin, but we can pick any of the 3 that do have a twin in the other class. So that would be 3 out of 12, which is of course 1/4. What about our next choice? Once we've picked that child, one of those 3 children from the first class, moving on to the next class, what's the probability that we now get a twin for the second class? The answer wouldn't be 3 out of 25, it would be 1 out of 25, because we need the sibling twin of the child we already picked from the first class. This is not like a whole new question that just starts off at the second class. You have to take account of the fact you've already picked out a child from the first class. And once you've picked out a child from the first class, you then have to get that specific child's twin in the second class. So yes, for your first choice, it doesn't matter which of the twins you pick. So when we went to that first class, the 12 children, and we walked into that room, we could pick any of those 3 kids that had a twin in the other class. That's fine. We didn't care whether it was one of them or the other, as long as it was one of those 3 kids that had a twin. But once we've picked that kid, held their hand and moved them out of the room, and we walked towards the other class, we now need to get that twin's sibling twin for the other class. So there's only one child in the larger class of 25 who's the sibling twin of the child we've already picked. So that's 1 out of 25. You've got to think one choice at a time, taking into account the choices you've already made. It's a bit like life. And as before with probability, we multiply these, and if you multiply those, 1/4 times 1 out of 25 is 1 out of 100, which is 1%. These are understandably tricky probability questions, and if you're not trained in them, they're very easy to get wrong. So don't blame yourself if you didn't get these questions. But now you've seen the trick and these kind of questions aren't so unexpected to you anymore. I really hope it comes up in the test now for you so that you can get yet another question type correct. If you learned anything at all, please do leave a like and a comment, and I shall see you in the next video.